Hi, hello. Myself Chandrasekhar Pri from 18 College of Engineering, working as an assistant professor in Department of Electronics and Communication. Today I am going to give a brief introduction of Microcontroller Laboratory of V2 syllabus. The subject code of this Microcontroller Laboratory is 18ECL47. The course objective, course outcome and conduction of the practical exams are as follows. First is, what is the main objective of this microcontroller laboratory? The microcontroller laboratory objectives are as to understand the basics of microcontroller and its application, and to know the depth knowledge of 8051 assembly languaging programming, and to understand how to control the devices using an C programming, the concept of IO interfaces for developing a real-time embedded system. So these are the learning objectives of this course Microcontroller Laboratory. After once the student has completed its laboratory, what is the outcome of this? So the course outcome of this 18 ECL47s are, the students will able to write the assembly language program in 8051 for solving the simple problems that manipulates input data using a different instructions of sets of 8051. Second thing, students will able to interface the different input and output devices to 8051 and control them using assembly language program. Interface the serial devices to 8051 and do the serial transfer using C programming. These are the what the students will learn after completion of this laboratory. And the conduction of this course practical exams are, all experiments are to be included for a practical exams, whichever the experiment we have been done, that is according to the syllabus. And students are allowed to pick only one experiment from the lot, and student has to strictly follow the instruction as printed on the cover page of a answer script for breaking up of marks. And if the students want to change the any program or an experiment, it is also allowed, but only once, and the 15% of the marks which is allotted for the procedure is made to be 0. Next we'll see what are the laboratory experiments. So in these laboratory experiments we have got two parts, part A and part B. So the part A experiments are data transfer. So in a data transfer we are going to see how the blocks are moving, how the blocks are exchanging, how the elements are sorting, and how to find the largest element in a given array. And the second experiment or a program is an arithmetic instructions. So in this arithmetic instruction, addition, subtraction, multiplication, division, square, cubes are done or executed. And third one is a counter. Fourth one, boolean and logical instructions with the bit manipulations. Fifth one, conditional call and return. Sixth one, code conversion. Under this code conversion we are going to convert from BC2 to ASIC, ASIC to decimal, decimal to ASIC, hexa to decimal, and decimal to hexa. And finally in a software, that is in a part A, the seventh program, that is program to generate a delay and programs using a serial port and on chip timer and counters. And next the part B are as follows, which is our interfacing. So in that interfacing we are going to first interface a simple toggle switches which is going to turn on and turn off the LED to the 8051, and we write a C program for the data transfer and receiving a set of characters serially by interfacing 8051 to a terminal, and we'll write an assembly language program to generate a waveforms using an ADC interface, and also step up motor to an 8051 to rotate the motor we are going to interface, and we are going to display the LCD that is characters on the LCD which has been interfaced to 8051, and finally we are going to see the interface of ADC 0804 and convert the analog signals into it. So these are the laboratory experiments what we are going to be seen in this, and we'll look at to the a different, that is an introductions or a basic of an microcontroller 8051 family. The most universal employed set of an microcontrollers comes from an 8051 family, and this 8051 microcontroller persists to be an ideal choice for huge group of an hobbyists and an experts. In this course of 8051, the humankind become eyewitness to most groundbreaking set of a microcontrollers. The original 8051 microcontrollers was initially invented by the Intel. The two members of this 8051 families are 8052 and 8031. The 8052 microcontroller has a 3 timers, and it has gotten 256 bytes of an RAM. Additionally to it has all the features of a traditional 8051 microcontroller. So we'll discuss what are the features of this 8051 microcontroller in our upcoming slides. And 8031 microcontroller family is an ROM less, that is read only memory less. Other than it has all the features of a traditional 8051. For execution, any external ROM of a size 64K bytes can be added to this chip. So this 8051 microcontroller brings into a two different sorts of memory, such as NVRAM, UVRAM, UV EEPROM, and a flash. The 8051 is the basic microcontroller which is used to learn the embedded system projects. And the features of 8051s are, it has got an 8-bit microcontroller launched with a 40-pin DIP, where DIP is called dual inline package. It has a 4 kilobytes of ROM and 128 bytes of RAM space, which is inbuilt. If desired, 64 kilobits of external memory can be interfaced into the microcontroller. There are 4 parallel 8-bit ports which are easily programmable as well as addressable. And this microcontroller has chip crystal oscillators which is integrated in the microcontroller, which has an crystal frequencies of 12 megahertz. In the microcontroller there is a serial input output ports which has a 2 pins, and this 8051 microcontroller has a timer of 16 bits which are incorporated into it. These timers can be employed as a timer for internal functioning as well as counter for external functioning. The microcontroller comprises of an F5 interrupt sources, namely serial port interrupt, timer interrupt 1, external interrupt 0, timer interrupt 0, external interrupt 1. The programming modes of these microcontrollers includes a general purpose register, specific function register, and a special purpose register. By using these 3 modes of registers, we can be write or we can be do the programming in a microcontroller. Next we look at to the internal architecture of a 8051 microcontroller. So in this I am not going to discuss all the blocks, so only the main blocks we are going to be discussed in this. The first block what I am going to take is an ALU, which is an arithmetic and a logical unit. So all arithmetic and logical units are carried out by the ALU unit, which addition, subtraction with carry and multiplications are come under an arithmetic operations, and logic of AND gate, OR gate or an XOR comes under an logical operation. Next we have gotten a program controller, which is shortly called as a PC. So this program counter is a 16-bit register and it has no internal addresses. But the basic function of this program controller is to fetch the data from the memory, the address of the next instructions that to be executed. The program controller holds the address of the next instruction residing in a memory, and when a command is encountered, it produces that instruction. This way the PC or the program counters automatically does an increment and holds the address of the next instruction. And registers, this plays a very important role in a microcontroller programming. So these registers are usually known as storage devices. 8051 microcontroller has a two register. One is register A and register B. So where this register A serves as an accumulator, while register B serves as a general purpose register. These registers are used to store the output of an mathematical and an logical instructions that are being performed. The operations of addition, subtraction, multiplication, divisions are carried out by the register A, whereas the register B comes into a picture only when the multiplication and the division functions are carried out by the register A. So this register A is also involved in a data transfer between the microcontroller and an external memory. Next we look at to the pin diagram of an 8051 microcontroller. So in this 8051 microcontroller we have got a totally 40 pins, where the each pins will perform its function which is specified for the particular pin. In that we are going to see only the few pins. In that the first and foremost pin number 1 to 8. Pin number 1 to 8, that means 0 to 7, or from a P1.0 to P1.7. These pins are configured as an input or an output. Whereas pin number 9, which is called as an RS, which is a reset pin or a reset input, when the logic 1 is given to this pin, it disables the microcontroller and clears the contents of the register. If the logic 0 is applied to this reset pin, the program starts execution from the beginning. Next, from port, that is from a pin 10 to 17, from pin 10 to 17 are refers to as a port number 3 pins, so where each of these pins can be served as an input or output, which can be used as an alternative functions. And pin number 10, which is called as an RxD, that is serial asynchronous communication input or a serial asynchronous communication output. And pin number 11 is an TXD, serial asynchronous communication output or an serial synchronous communication input. And pin number 12, which is called as an interrupt 0 input. Pin number 13 is a interrupt 1 input. Pin number 14 is a counter 0 clock input. Pin number 15 is a counter 1 clock input. And pin number 16 is an WR, write to external RAM. and pin number 17 is an RD which reads from an external RAM. And pin number 18 and 19, these two pins, pin number 18 and 19, are called as an XTAL1 and XTAL2. So where these are the internal oscillators input and output. A quartz crystal which specifies the operating frequency is usually connected to this pin. Instead of it, the resonance can also be used for the frequency stabilators. In the latest version of microcontroller, the frequency what we are going to be operated will be up to a 50 hertz. And pin number 20 is called as a ground pin, and pin number from 21 to 28, that is we call as a port 2. So these are an use, that is no intention to use the external memory, then these port pins are configured. In case of external memory is used or the higher address bits are used, at that particular point of time, A8 to A15, A8 to A15s will be appear on this port. And pin number 29, which is called as an PSEN, if the external ROM is used for storing a program, then a logic 0 appears on it every time the microcontroller reads a bytes from the memory. So PSEN means program stored enable. And pin number 30, which is an ALE, that is address latch enable, so which going to read from the external memory, and the microcontroller puts the lower address bytes A0 to A7 on P0 and activates the ALE output. And pin number 31, which is called as an EA pin, that is external enable. By applying a logic 0 to this pin, P2 and P3 are used for a data and address, that is port 2 or a pin 2 or a pin 3, that is port 2 or port 3 can be used as an address or a data bus. Next, pin number from 32 to 39, which are called as a port 0 pin, so which will be acts like similar to a port number 2. If the external memory is not used, these pins can be used as a general input and output pins. And finally, we have gotten a pin number 40, that is an last pin, which is called as a power supply of a microcontroller. Next, this is a pin configurations of an 8051 microcontroller and internal architecture of an 8051 microcontroller. Next, we'll see the introductions of a microcontroller lab. So microcontroller lab is mainly used with 18CL47 course code, and the labs has the following equipments as software tools that are being used, that is keli, Musion and then Flash Magic. These are the software tools that are going to be used in the microcontroller lab. And application of the microcontroller in industrial control devices are like as follows, that is industrial instrumentation devices, process control devices. Applications of microcontroller in day-to-day life devices we are going to see are light sensing and controlling devices, temperature sensing and controlling devices, fire detections and safety devices, industrial instrumentation devices and process control devices. So this is a small introductions of a microcontroller and its lab, that is what are the software that we are going to be used in the laboratory. Next, we'll see how to run a program by step by step. So here I am going to show the execution for a software programs, and later part we'll discuss how to interface the devices or peripheral devices with the 8051 controller. The first step of this lab in a software program, not interfacing, I am saying software program, we need to select a keli Vision software which is on the desktop. And the second step, so select a project. Under a project, go for a new micro vision project. So when you select the new microvision project, you'll get a dialog box of a create new project. So in this create new project, we need to enter your file name and then we need to save it. So once it has been saved, so in a step number 4, we need to choose. It will be navigated into a select device target. In that select device target, we have been so many databases of a microcontroller. So in this so many database of a microcontroller vendors or devices, we need to select the whichever the microcontroller we have been using for the laboratory. So right now in our lab we have got an ATML. So we are going to select the ATML and we're going to click OK. Next, in a step number 5, once the ATML has been OK, then we need to select the which devices I'm going to be used. So here the device what I'm going to use is an 8089C51 microcontroller and click OK. Once it has been OK, it will ask for the a standard 8051 startup code to the project need to be added or not. Save it as yes. And once it has been yes, it will be navigated and it will indicate that the target has been created, and make ensure that whether this startup.a51 file is added it to the target or not. So how to verify it? So when that in a project panel we have gotten a target 1, so expand this target 1 and expand this source group 1. So there you are going to find this startup.a51. So this will confirm that the target has been created, not your file, the basic target has been created. And in step number 7, go to the file, now select the new, and once the new is done, your editing window will open, and in this editing window you need to type your program, so which has been shown here. So once the program has been typed, so then go to the file and save that file, or you can use the Control S. So while saving this file, that is whatever the program you have been written, so here you need to save the file as an .asm. So here you can see that give a file name path with the .asm extension, and once you need to verify, you need to create your usn folder. So whatever the program you are going to done in that file only, you need to save as an file name .asm, and this is click it on the save. And once it has been done, here you need to add the file in a target, that is in a project panel. So to add the project, so right click on the source group. So here write it on the source group. So when you write it on the source group, a pop-up window will open. So in that pop-up window you select and add files to the group. So once you select add files to the group, it will navigate to which files to be added. So in that you need to first say which type of the file, whether you are going to add the C file or whether you are going to file the exa file or an objective file or a link file or a library or a ASM. So here what I have been saved my program is in an .asm. So hence I am going to select the ASM source. From where I need to select, wherever the program have been saved in a folder, right? From that folder you need to select a source. So once it has been selected, it indicates which is the program that have been saved. So select your program file and then click on the add to the file to the source group. So notice that whether your file has been added over here. So once the file has been added in the project panel, next you need to build the target. So just to check whether error has occurred or not. So to build the target, so click on the project and navigate into a build target, or you can directly press as an F7. So once the target has been built, we need to be verify in a build output window whether we have gotten errors or any warnings. If there is any errors, go back to the program and correct the errors, and the output window shows a line where the error has been found. So please do read the comments or the lines in a build output. So after correcting the error, go back to the step number 14 and repeat the process until there is an a zero error. If the warning is there, no worries, but error should be zero. So till this clear, you need to be follow the step number 14. And once the error has been free, next we need to start the debugging option. So to do the debugging of a program, so go to the debug menu, and in that select then a start stop debugging section. So when you select or click on a start stop debugging section, then click on a OK. And in step number 16, selecting an output window. How to select an output window? By choosing approximate output window, like an memory serial logic. If you are, it is an address serial, if you are using an any serial communication or data transfer, you use an a serial. And logical analyzers, if you use any type of an a logic according to the program output. And also type in a input parameters according to your program. And next step number 17, we are going to execute. So to execute this whatever the program we have been written, so debug, so we need to go for a debug and select the command option called as an run. So that will execute the one time execution, and if you press F11, it will execute in a single step, that is line by line. But very important, be a note, make a note of it. In the memory window, enter capital X is to 0x8100 for accessing any external memory, and I is to 0x30 for accessing internal memory, where X stand for external memory, I stand for internal memory, and C stand for accessing code memory. So generally we won't use a C, just we use an X and I, that is the internal memory and an external memory. So these are the 17 steps that are used to run a program. So this is a small introductions to the microcontroller laboratory. So in the next section, we are going to discuss, or we are going to give a logical of a program of first program, that is a data transfer. So thank you one and all.